in lab 3, we're going to pick up right where we left off with lab 2. We're going to do some more select statements, getting data out of our database. The only difference this time is we're going to add just a little bit of complexity to it, meaning that we're going to focus a little bit more on our aggregations, and then we're also going to start doing joins. And joins are really, really important when it comes to writing SQL. Because very rarely are we going to select data from one table. We want to select it from two tables, and more specifically, we want to be able to match that data. And so that's kind of what we're going to be focusing on today, is learning how to go about doing that. So with lab 3, you'll notice that we're going to reinforce quite a bit. And the new stuff we're going to do is we're going to learn how to write 2 table queries with basic aggregation functions. We're going to learn how to do the group by and having clauses, and we kind of touched on that a little bit. And then we're going to learn how to use outer joins. And the joins, we'll talk a lot about joins in the next week or so. So you should be good with that. So anyways, we're going to kind of just jump right into it this week, because we're going to use the lab as kind of our guide on how to go about new stuff. So step 1 is just like we've done in the past. So you select the number of rows in the member table. It's pretty easy, and I'm actually not going to show you how to do it because you actually did this in lab 1, and I also want to have you reinforce it. So I'm going to let you go ahead with lab 1. Lab 2 is you're going to write an unfiltered query that returns the count of the number of rows for a non-aggregated column in a table or result set. So basically what we're going to do is we're going to find the total number of last names. And just again, as a hint, we may have covered this last week, so it shouldn't be anything new. I kind of want to let you guys practice just a little bit without me giving you the answer. So I'm going to let you do that one as well. All right, and then step 3 is going to be another one of those, just add a little bit. So again, I'm not going to do too much here with step 3 because we did cover this quite a bit. All right, but on step 4, this is where we're going to begin to do multiple table select statements. So it says write an unfiltered query that returns the count of the number of rows for a non-aggregate column in a result set from an inner join of 2 tables. So I always like to refer to inner joins as the bread and butter of SQL joins, and I'll show you why. So as you can see here, we have this nice little diagram. It shows our member and contact tables, which we should be beginning to start getting a little bit more familiar with now that we're selecting data from them. You can see that the member table has things like our credit card numbers, our account numbers, what type of credit card we have, that sort of thing. And then our contact table has first name, middle name, last name. But there's one key important thing. If you notice, contact table has this member ID here. And that member ID is actually what connects these 2 tables. You can see the little line here that's crowfoot, because multiple contacts can belong to the same member, which we'll show here in just a minute. So let's, this is kind of where I'm going to deviate just from following the lab entirely, because we are going to just talk about joins here for just a minute. So let's get to our lab 3 so I can have a place to put some code down here. All right, so there's that. And then I'm going to get here with my terminal as well. Make sure that we're all set. CIT225, Oracle Lab 3. All right. All right, now we're all logged in. So this is where we're going to put our code. And like I said, we're skipping all the way to step 4. So I'm just going to go ahead and start it right here at step 4, where we're selecting stuff. It's not like we're making any changes to our database. We're just pulling some data out. So it's okay to skip those first ones for me. You'll want to make sure you do them if you want points. But So for step 4, what we're going to do is we're going to gather our data from 2 tables. So real quick, just in this terminal, I'm going to describe member so we can kind of see what's going on, and describe contact. So we take a look at these two tables, and what I always like to do is I like to look for the common denominator between the two. And you'll notice that they all have these created by, creation date, last updated by, last updated date. That's just for auditing purposes. So you can track, okay, who changed this row, who updated this row, kind of a thing. So, I like to kind of ignore those, and you'll hear me refer to those as who audit columns, because it tells you who and when changed the row. So even though those ones are all the same, you can kind of ignore those, but we're kind of looking for something that matches between the two. So as I'm looking through here, if I look at member, it's got a member ID here. And then if I look at contact, it's got a member ID here. And that actually is our common denominator. And that's how we're going to connect these two tables. And I always like to use a spreadsheet example. Well, let's just go take a look here. So if I select everything from contact, let's say that we want to know what, let's see, let's make this a little prettier. Set line size 250. All right, so let's say we want to know what Randy Wynn's credit card number is, right? Just a typical little scenario. We want to know what Randy Wynn's credit card number is. And we know from our tables and such that our credit card numbers are in the member table. There's our credit card number. So we want to get his credit card number for Randy Wynn. I think it's actually a her. Let's say Brian Wynn. We're gonna go for Brian Wynn, since my brain's already on he. So we're gonna get that credit card number for Brian, and we need to know a way to match them because they're in 2 different tables, right? So if I select everything from contact, I can see it here. Now, if we were going to do this logically without actually connecting the tables, I could say select everything from member. And I bet you that, if we're looking at this, we might be able to figure out what Brian Wynn's credit card number is. So let's play a little game. If someone wants to, go ahead and put Brian Wynn's credit card number in the chat if you think you can guess what it is. I wish I had the little do. And actually, you don't have to put the whole credit card number. Go ahead and put the 11222333444. Perfect. So Breton got it, and for those of you who are confused on how that was going to work, maybe you're just shy to do it. So if we look here at Brian's information in contact, you'll notice that the member ID is 1001. And if we look down here, we can go to member ID and see that the member ID here 1001, and that is his corresponding credit card number. So basically, we're going to make the computer do all that matching for us, but it's really not too complicated, because all we're doing is we're saying, look, take this row. Sorry, my kids are screaming. If you take this row from contact and we attach it to the row and member based on the member ID column in both tables, then we have a match. Because if we randomly put it together, we get all sorts of crazy things and wouldn't have accurate data. So that's what we're doing with our select statements. And the way this works is, and I think I've brought this up before, but with telephone tables or email tables, I think I've brought this up with email tables before, is that here we have someone might have multiple email addresses. So just back to this example, here we have a person table, and we have Frodo Baggins, and he is person ID 1, and we can see that his emails are Frodo@theshire.com, Frodo@ringbears.com, and almost a wraith at Rivendell.com. And that's all based on his person ID. So you can, it's just a matter of matching. It's just like playing that matching game that you always play with your kids, or, all that. And that's essentially what we're going to do. Now, one important key fact here is that these little things have names. And that's kind of what I want to hint on while we're on the topic. And that is, and I think I have a right here. So we have primary key and foreign keys. So just another example with the same kind of thing. This is our person table. And our person ID is the primary key. It's just the one that kind of counts up through. And I think we talked about this last week, but it uniquely identifies a row. So there will never be multiple person IDs that have the same value because it's a primary key. And once we define it as a primary key, it's unique. And so we use that primary key as a way to uniquely identify things. So for example, if we are adding emails and we want to say, oh, this email belongs to only Frodo Baggins, right? Then we would put the person ID as whatever his person ID is, because there can only be one person ID 4, and that person ID 4 belongs to Frodo Baggins. So in the primary key is the primary key of that table. And then the way I like to remember the foreign key is because it's the only piece of data that doesn't belong, or it's a piece of data that doesn't belong that actually belongs in another table. So for example, in the email table, does a person ID, besides assigning who that person is, it doesn't have much to do with the actual email data itself. It's foreign. This is the only data that's ever should be duplicated across your database, which we'll talk a little bit more when we get into the design portion. But when you're designing a database, you don't want to have places where you type a name in twice, for example, right? Because what if we put first and last name in the email table and then someone wants to change their last name? Well, now we have to remember to change it twice. So we don't really want to do that. Instead, we want to connect data. We want to make data work for us. We want to make it clean, and it's called data integrity. We want to make sure our data has lots of integrity so we can always rely on it because it's worth a lot. So that's essentially what we're going to do. And in this case, in our little scenario, the primary key was member ID, and the foreign key was member ID in the contact table. So in these cases, lots of times the primary key and the foreign key have the exact same name. What the difference is which table they're in. So the member ID in the member table is the primary key. The member ID in the contact table is the foreign key because it's the foreigner. And so, if you really want to drill it into your head, you can listen to a Foreigner 4 soundtrack while you code your stuff. Is it possible to have more than one primary key per table? Absolutely. So let's get a good example here real quick, right in our database. So if we take a look at the street address, or is it address? Let's try, no, it's telephone. If we take a look at the telephone table, you'll notice that not only does it have a contact ID, which is a foreign key, but it has an address ID, which is also a foreign key. Oh, and you asked primary key. No, you only have one primary key per table because that primary key, so to back up, you can have multiple foreign keys in a table, but only one primary key. Now, to branch off that question, is it possible to have a foreign key that references a non-primary key? And the answer is yes. We can match on whatever we want. However, common practice, if you want the first normality, it has to be matched on primary key values. So good question. Only one primary key. Okay, so let's start writing a little bit because we want to see this in action, right? So we want to actually see this. So what I'm going to do for step 4 is we are going to we're going to write this a little bit. So let's take a look at our instructions again. So we want to select the last name from the contact table and the account number and credit card number from the member table. So kind of similar to what we just did, right? So we want to get the last name and the account number and credit card number, right? Similar to what you might do if you're like sending something off to billing or something, something like that. So let's get started. So just like all of our other stuff, I always like to start with what we're selecting. But with joins, it gets a little funny. So I'm going to show you what I like to do. I like to just select everything. And I'll show you why here in just a minute. So I like to select everything, and I like to kind of build it up as I go. So we know we're starting with the contact table, right? Just like we did in our head. That's what I kind of like to show this little example here first, because most of the time we overcomplicate this process. Because if I gave you these two, tables and said, oh yeah, match these, you'd be able to do it just that fast, right? Like Breton did it super fast. And so we just got to think through it just a little bit. And that's why I like to go one step at a time. So we're going to just start with the contact table. And we don't have to go crazy, go with your own level. I'm going to go really slow just so you can see it. We're going to select everything from contact, and there it is. Now we know we want to connect to member. And just like we talked about, we want to find out what we have here. So I'm looking at all my contact stuff, and then I can actually say select everything from member. And then I take a look here, and okay, so I want to go from contact member ID, right? So let's go ahead and put that in there. From contact. So then we say inner join member. So where we want to go. We want to go from contact table to the member table, and we're going to do an inner join, and we'll talk a little bit about what that means here in just a minute. And then how do we match it? Well, we want to go from contacts member ID. So we say contact.member ID. And we want that where, for example, 1001 is equal to 1001. So contact.member ID is equal to member.member ID. Now, when I run this, oh, I'm missing one keyword, and I know what I missed. We have to specify how we want to match, so we want to say on. So select from inner join on, and the on is just how we match. Let's try that again. And there we go. So now you'll notice that we get quite a different result set. And basically what it's doing is it's gluing all of the member records off to the side of the contact records and appending them. So for example, for Brian Wynn here, you'll notice that we get his credit card number of 1000 or 1111-2222-3333-4444. But the important part is that his member ID here matches his member ID here. And obviously that's going to be the case because that's what we specified. So now we have our join working, and we check to make sure it's working. And so now we want to just select what information we need. So we want the last name from the contact table. So I go contact.last name from the contact table. Now, if I did this, we just get the last name. So it's just like it was before. All that data is still there. We just only show the last name. So we want the last name from contact, and then the account number and credit card number from member. So let's do that. Let's make it nice and look good, I guess. So then we want the member dot account number and the member dot credit card number. Now, when we get this a run, we get this nice little output that tells us exactly what credit card number we have here for different people. Now, one thing I want to point out is you'll notice that there's 2 wins here. And the reason there are 2 wins is because there's 2 win people in the contact table. So to make this a little bit easier to see what's actually happening is if I add contact.firstname, it will make a lot more sense. Because like I said, even though we don't see all the data, it's all there. So in this case, you can see, oh, there's the difference, right? That's just one of the first one's Randy's and the other one's Brian's. But you'll notice that they actually share the same account information, similar to if you have multiple profiles on your Netflix account, is a great example. You might have one account that, you know, one credit card number, one account number, but multiple people tied to that same account. But that's basically how those join works. And to tell you a little bit about how those inner join works, I'm hoping some of you saw this in the announcement, but if you Google SQL joins on Google image search, you'll get something that looks like this. And this is a great resource. It's a fantastic resource. And like I said, the inner join is what I consider to be the bread and butter join of SQL. And this is basically what we're doing. So in this case, A and B are just whichever one comes first. So in our little scenario, table A is contact. So our A table is contact and member is our B table. And so when we specify an inner join, we're only going to get records that are here. So ones that match, right? And I guess just as a little example, it doesn't matter on an inner join, it doesn't matter. But when we get into left joins and right joins, it does matter, because depending on what you want, you'll get different things. So for example, if I were to, let's just real quick insert a table here, insert a record here. So insert into member. And wow, what does member have? Let's pull that up so we can see here. So basically what I'm going to do is I am just going to real quick show you what it looks like when there isn't a match, so we can kind of see the difference, because it will matter eventually which one's A and which one's B, which one comes first and which one doesn't, based on what you want, and also based on efficiency. And we'll talk about that here in just a minute. Let me get this in there. Account number, credit card number. And no, I'm not going to put my real credit card number in there. Be nice though, wouldn't it? All right, there we go. Let's see, let's just select everything. All right, now I can see what we're doing. So my credit card type is going to be the exact same as everybody else's, which is 1004. My account number is going to be G12 or G12 dash that. That's my account number. I guess to make it uniform, we'll do that. My credit card number is going to be that'll be my fake credit card number, and credit card type is 1005 like everybody else's, and then actually my member type will need to be 1003 actually. And that one created by is 1. All right, let me hurry and get this row inserted, because basically what I'm going to do is I'm going to create me a member account. So now if we select everything from member, so my account is this one. It's member ID 1009. So now I'm going to leave this there. If I do this, let's have a little poll, right? So based on this, if I'm selecting an inner join between contact and member, now I just inserted a new row into member, but I didn't insert a new row into contact. Based on our inner join, where A is contact and B is member, is my account number going to be in the result set? Perfect, getting lots of no's. And that is absolutely right. So, yep, no, it is not going to be in there because there's not a match. So just to prove a point here, if we run this, I am not in the result set. And in fact, neither is my account number or credit card number because we did an inner join. Now, poll number 2, if I wanted to see my account number in the results set, so essentially what we're saying is, look, I want all the account numbers and I want them whether or not they have a person in their account, right? Let's say we're cleaning data. We want to see all the account numbers. Now, remember, this is where order matters. Should I use a left join or a right join? Remember, we're going from contact to member. So contact would be A and member would be B. Any guesses? Perfect. Yep. Bracken got it. We're gonna do a right join. So just to show you what it would look like if we did change this inner join to a right join. Now you'll notice that my account number down here is here, and that I don't have a first or last name assigned to it because there is no contact to tie to. So you can see how you can use different joins to garner different data. So for example, let's say that we wanted to find all the credit card numbers who don't have a person tied to it, right? Let's say we're cleaning data. We want all the credit card numbers that don't have a person assigned to it. So in that case, what we would do, we can actually take this exact same thing here. And we would actually say, because we want everything on the right, whether or not they have a match on the left, so exactly like what we did, but we're just going to add a where clause and say where contact.memberid is null. And then we only get the one record that doesn't have a match. So you can see how doing different joins will, depending on what you want to accomplish, what data you want to get out of it, you can do different joins. And in this case, like I said, inner joins are usually kind of the go-to because most of the time you're only looking for matches. But if there may be times when we're looking for everything, whether or not they have a match or not, and in that case, you'll have to either do a left or a right join. But in this lab, we don't have to worry about it. We're just doing inner joins. So let's take a look at our instructions again. And we did this, assign a column alias of total names to the count function call, join the member, and it kind of tells you how to join them. So don't fret too much. It'll give you hints. But it basically wants us to add an aggregation to this. Basically, we want to see total names for each one of these. So just like we've done in the past, we're going to add it right here. We're going to say count. And then as is to give it an alias. You'll notice it says give it an alias of total names, and that's the alias is when we say as, and then we can say total names. Now, another little, I guess, poll, quiz, pop quiz. If I were to run this right now, would it successfully run or would it give me an error? We got one run, okay. Any others? Any other guesses? Run, 2 runs? Okay, we're gonna give it a shot here. We're gonna see. Oh, we get an error. And the error we get, if you remember right from last week, if we have an aggregation function in the select clause, we have to have a group by clause. So that's a tricky one. And it's one that I like to use a lot because this is probably one of the biggest like errors that I see come up, that people are like, I don't know what it's asking me to do when I see this error. But just remember, if you do any sort of aggregation function, we have to tell it how to count them. Because if we didn't, right, if we wanted just the count of total names and we didn't provide a group by clause, this would just be 1 all the way across the board, right? Because it's just going to count the rows. We have to tell the computer how to combine multiple rows to count. And so if we go to our original results set, where it was just the last names, we had one here somewhere, right here. Basically what we're wanting it to do is, instead of saying win, Visquel, we want it just to say win 2, Visquel 2, Sweeney 3, Clinton 1, Moss 1, Gretzel 1, Royal 1. And so basically we have to tell it how we want it to combine those. Now, general rule of thumb that I like to do is it's just your select list minus the aggregation query. So I actually usually just take and grab this and I say group by, and then I paste it. Now it should run. But we forgot to take the first name out of it. And you'll notice here that we still get 1 all the way across the board, kind of like I was telling you about. And that's not helpful, is it? So what we need to do is we need to take out the first name column. Make it a little less unique, because that's how we want to group them. If we group it by the first name, everyone's just going to have 1. But if we take away the first name and group it only by the last name, account name, number, and credit card number, now all of a sudden we have the results that we were expecting. All right, well, that was, oh, and then we have one more thing. So then after we do that, it says filter the aggregated results set with the having clause. And basically we want to return true when the count of the aggregated rows is greater than 1. So basically we want to see where we only want to see people that have more than 1 person attached to their account. So the having clause is not too bad. Basically, you just put your aggregation in, and we're going to say where it has a count, having a count that is greater than 1. And to use this having clause, you have to have a group by. Otherwise, it would just be a where clause. So if we say having a count greater than 1, now all we get are those people that had more than 1 person tied to their account. So the Win, Sweeney, and Visquel. Is that making sense to everybody? Go ahead and throw a yes in the chat if you think you're following along pretty good. Yep, there's 1. If it's not, go ahead and say no, and we can keep going. I try to gauge speed off it. I'm getting lots of few yeses. But if you're feeling a little shaky, just feel free to let me know which part. There's lots of yeses coming through. And even if you're the only one that doesn't get it, that's fine. Jackie says, yes, I think so. So, okay, shaky. Let's give it one more, and then if it's still shaky, we'll keep going. And just so you know, the best way to really get this is just to go and try it. right? And so even though, I mean, you're going to be doing it with the homework, what I like to kind of tell people is, just, kind of play around and say, oh, this is my scenario. I want this and this, and then try to get it. But we're gonna do some more practices here. So this is another fun one because that one we got the credit card number. Now we're gonna kind of go the other direction, right? We're gonna go from contact to address. We're gonna get everybody's city and state. Um, Essentially, we're gonna get their city state data. So let's go ahead and do this. Now this one's gonna be very similar. We're just gonna add one more little kind of trick to this. So let's basically we're going to kind of do a similar query. We're going to get the last name, first name. Let's call this random stuff not lab related, so people don't get confused. Let's go ahead and run our step 5. So for step 5, it's going to be really similar, except for we're not doing it with member, we're doing it with contact. So again, like I said, I like to just start with the basics. We're selecting everything from contact. And I'm not going to run it this time because we've seen it before. Actually, no, let's do run it because we have to know what we're going to match on. And it tells you in the instructions, but I like to show you how to do it because that's usually what we do. So we know we're going from contact to the address table. So let's select everything from address. Now, another pop quiz. What is the name of the column? And hint, it's the same name in both tables. What's the column name that we're going to use to match on? Perfect. Bretton's got this, you can tell. Contact ID. So, yep. And just so you know how we go about that is we're going to look and see what matches between them. And if we look at this, it's pretty quick to tell. And once you kind of get the feel for whoever designed the database, what they've done, you can usually find them pretty quick. And in fact, in this case, we don't even really have to look. We could just write it if we wanted to with a best guess. So contact ID is our primary key in the contact table. And then contact ID in the address table is a foreign key. And that's where we're going to match. And most of the time, if the names are the same, you can assume that the data is going to match between them. So that's what we're going to do. We're going to match on the contact ID. So we're going to do this again with an inner join. So we're going to say select everything from contact, and we're going to inner join that with the address table. Now we got to say what we want to join on. We say on contact.contact ID is equal to address.contact ID. Right? Because the contact.contact ID is equal to the address.contact ID. Right there. And it never hurts just to take a look, just like that. Because if you can do it just by looking at the data, which we probably all have done, we're looking at 2 spreadsheets trying to figure out something. You've probably done this exact process. It's just a matter of typing it out in SQL. So we're going to grab this data, and we could just run it. And that's going to give us a whole mess of data, but it is everybody's addresses. So now we're going to kind of narrow it down to just the data we want to see. And we want to see the last name, city, and state province. But you'll notice there's a special word in step 5, and it says unique here. And unique means we don't want any duplicates. So let's just start going, and we'll see how this pans out. So we're going to select contact.lastname, then address.city, and address.state_province. Now, if I run this, we should be able to see our results a little better. But you'll notice that just like we had with our members query for step 4, we have duplicates. You'll notice that Wynn, San Jose, and California, it's actually there twice, right? And so what we're going to do is we want to select a unique result set, meaning that we only want to see Wynn, San Jose, California once. And this is pretty easy. If we add the distinct keyword right here after select, it's going to only return unique rows. Now that's all the way across. So if I had Win San Jose, Texas, I don't know if there's a San Jose, Texas, but if there was, we would still see a Win San Jose, California and a Win San Jose, Texas. Basically, it's like a unique all the way across the board. And so now we went from 12 rows to 8 rows, which means that 4 of those rows were duplicates. So you can see we kind of just went the other way, and then we select unique rows because we got rid of 1, 2, 3, 4. So there's our 4 rows, and then we're left with the results. Does the distinct make sense to everybody? Perfect. And hopefully seeing another select statements or another join is starting to just make a little bit more sense. Let's see what the next one is. All right, so the next one you're going to do the telephone table, and I don't want to do this one because it's about the same, except for you add a sort and stuff like that. So I don't want to do that one too much. So what I'm going to do real quick is I want to show you an easier way to do this. Not an easier way, but you can save some keystrokes. So we have this query here. What I'm going to do is I'm going to write the exact same query, but I'm going to take some typing shortcuts. So I'm going to say select distinct, just like we did before. But I'm actually going to select everything from contact, but I'm going to give it a shortcut. So I'm going to say C, contact space C, inner join, address space A. Oh, I need my join, and then I'm going to say on C.contact ID is equal to A.contact ID. You know, let's just pull this while we're here. Now you'll notice that this saved quite a bit of typing all the way across the board, because basically what I did is I said, I'm going to give these tables a nickname. And I gave contact a nickname of C and address a nickname of A. Now, if I run this, we're going to get the exact same result set. You'll notice they work the exact same. The only difference is we have a little less typing. And to set that alias, you just, after the table name, you just put a space and then the name. Now, we could do whatever we wanted here. We could call it con, but then we'd have to change it here, everywhere. It doesn't really matter what it is. Mostly people use it just to save some time. So if you want to use aliases, you can. If you're not quite there yet and you just want to focus on keeping it simple, do that. But just know that it is an option if you want to play with it. And after this week, you'll see me starting to do this a lot more. Because in fact, we'll get to the point where you actually have to use aliases because we'll use tables more than once. But these are the exact same query. One just uses table aliases and the other one uses the full name. Did that overcomplicate anything for anybody? Does that make pretty good sense? It's like assigning a variable name to your table. Okay, let's take a look at some of these other instructions. So step 6, you're going to go from contact to telephone. So, you know, let's just real quick, I guess, just so I can see how we're doing. If I select everything from contact and select everything from telephone. All right, looking at this, let's do another pop quiz. What column am I going to use in the on clause? What column am I going to use in the on clause and how I'm going to match? Any other takers? Bretton's answering all the questions. Anyone else with a different answer? Okay, contact ID. Looks like people are going to concur with Bretton, and that's right. So when you're writing step 6, you'll join on the contact ID, and it tells you, but just in case, it's always good. And I like that that means that you guys are starting to get it, which is important. All right. So you guys are going to do step 6. Let's see what step 7 looks like. So step 7 is from a single table, but there's one little thing about that. So let's take a look at this one. So we're going to just select data from the common lookup table. So we're going to get the common lookup ID, common lookup context, common lookup type, and common lookup meaning. So let's just get that far, right? Do step 7. We're going to select, what was it? Common lookup ID, common lookup context, common lookup type, and common lookup meaning. And you will get real sick of typing all that common lookup stuff. And we're getting this all from common lookup. Like I said, I kind of like to just go slow, one step at a time, make sure we're getting what we're looking at. So, and I also want to talk a little bit about what the common lookup table is. So the common lookup table is a table where we store, I'm not going to say random data, but data that doesn't really warrant a table of its own, but we want it to be in a table. So for example, I always like to use gender. So, we could put gender in a table. So like if we're recording someone's biological gender, we could put in the common lookup table a male and a female record, right? Where we would put that in there. Because maybe, and the example I always like to give is if you have someone typing in your data, they can type male in a variety of different ways. So for example, we could type male, M, there could be typos. And so, a lot of times, like when you see like forms and stuff, that's why they have those little drop down menus, right? And specifically, I guess what I'm building up to is this common lookup table is what drives the drop down menus. If we were going to build a web application that's tied to our database here, these are all values you would find in a drop down menu. So if I'm building a web application and we're going through a payment system, I might say, select the certain stuff that I need for my drop-down menu where common lookup context or where common lookup type is equal to or is like card. So if I was going to do a drop-down menu for all of our credit cards, we could do that, and then you could use the little drop-down selector like we've all seen before. And we're going to clean up this common lookup table in a future lab. It kind of is a little convoluted right now because it's one of those things that's actually a practice we're going to fix. But for right now, just know that the common lookup table is quite literally values that we commonly look up. To know how it's spelled, and basically we tie it into our database so that we never have to worry about, did they spell male? Did they spell all caps male? Did they spell with a capital M? Did they have a typo? Did they use all lowercase? Because you'll notice in this case, like for example, a Visa card is Visa _ card. And if we match that to here, it doesn't matter how they spell it. It will always just reference that record. And we can even change the spelling if we wanted, but it'll always reference the same record based on the primary key. So that's what the common lookup table does. Just so you know, it's just not just a random set of values. But we're going to start with this base query here because we're going to filter it, because that's kind of the whole caboodle. So it says filter the result set on the common lookup type. And we want common values that matches any of the following values. So now this gives you a hint, but anytime you see a list, like, oh, it can be this, this, or this, we're going to use an in operator. And just so you know, if you want to get some a nice little cheat sheet. Maybe there's other ones out there, but on db.tanacrypt.com, I tried to build this nice little SQL operator table that will show you these different ones. And so in is the one we're going to be using here when it's in a specified list. So where last name in this example is in Potter, Weasley, or Granger. And so that we're going to do this the similar thing here. We're going to use where common lookup type is in Blu-ray, DVD, full screen, or DVD widescreen. So let's go over here. And I like that little table I built because it gives you a nice little example. So you can almost just copy it and just change the names. But where common lookup type is in Blu-ray, DVD, full screen, or DVD widescreen. Now, if we run this, now we only get those ones. Now you'll notice we didn't get Blu-ray, and that's probably because I typoed something. Oh, it looks like there's a typo in here that I did, because if you notice it's blue-ray, not underscore, because I think technically Blu-ray, trademark Blu-ray is blue-ray, not two words. So if we change that to how it's spelled, now we get the results that we're looking for. So that's the in operator. Not too crazy, just in a list. All right, step 8 is almost, in fact, the hint tells you to start with the same query you wrote for step 7. So there you go. Step 8 is pretty easy, like I said. And then step 9 is almost the same thing, but basically you're going to pull the credit card type for member. And then step 10, it looks like we pull the returns joint from the member common lookup table. We get the common lookup ID, common lookup context, and the count of credit card. So 10 is where you get the count of credit card, basically as if your boss said, hey, what's our most commonly used credit card? We're trying to get a report on what credit cards are used, and we want to see if it's even worth dealing with all the paperwork to take MasterCard or to take American Express, for example. Pretty real life example. So I'm going to leave step 9 and 10 up to you guys because, like I said, a lot of this is reinforcement. There actually isn't anything too crazy here except for the fact that we're taking a join and we're adding a where clause. But one little hint here is you'll notice that the count of credit card column values that are not found in the member table. And it actually tells you to start the problem by starting with step number 9 solution. Now you'll notice that I kind of gave you a little hint earlier when we talked about, oh, this is how you would find that one member account that didn't have a contact account. You're going to do something similar. So we're going to leave step 9 and 10 up to you guys. Have a little fun. If you get stuck, please shoot a message onto Teams and we can, everyone can help you out. Does anyone have any questions? Really, this lab actually shouldn't take too long. I imagine that most of you will fly through it up to step 9 and 10, and then you'll have to think just a little bit, which is what I want. I want you to think just a little bit, but don't spend too much time stuck. I don't want it to get to the frustrating point. Just want you to put your thinking caps on because sometimes you just have to solve some problems. All right, any questions? Okay, so the crow's feet notation. There is actually a good reference, and it's actually part of UML diagrams. And actually, in the class material, there's a chapter out of the book, the MySQL Developer Handbook. Let me find it here for you. If you go to the syllabus, and then we go to the textbook section, the MySQL Workbench Data Modeling and Development. It's in chapter 3. Wait just a minute here, and I'll explain it to you in just a minute so it kind of makes sense. So let's go to chapter 3. And this is our data modeling concepts. Let's see if we can find it real quick here. Here we go. So yeah, in chapter 3 of this book, like I said, it's the MySQL Workbench one. And even though it's MySQL, it tells you, and especially on this data modeling systems, and basically what those little crow's feet mean, specifically the crow's feet, the one that has the 3, like this. See how it has the 3 little nubs there? That's a one-to-many relationship. So if another good example is our telephone table, one person can have multiple telephone numbers. Let's say they have a home phone, a cell phone, etc. So the contact can have multiple telephone numbers. So that's what those crow's feet mean. And if you want some really good explanation of the different relationships, I would highly recommend taking out and reading this little section here of this book, chapter 3, data modeling systems. And it'll talk to you about the different connections, kind of explain them really good. This is actually a really good chapter of the book. Okay, and then JP asks, how does an employer phrase that they want an inner join or an outer join? I feel like I'm always using left joins. And yeah, a lot of people use left joins if they just want to see it all, essentially, right? You kind of want to just see everything that you're, from the left on. So if I want to see all the contacts and telephone, maybe I want to see all the contacts whether or not they have a telephone. And so an employer doesn't always explicitly state that they want an inner join or an outer join. And in fact, a lot of times they don't even really allude to anything other than, hey, I need this. And that's why it's really important that you understand the consequence of using whichever join you're doing, because they can have large impacts. So a great example, let's say you're doing statistics for, in my world, I do a lot of statistical data on education. So for example, they might say, hey, I need to know what our average GPA is for this term of this year, right? Well, there may be students who don't have a GPA for whatever reason. Let's say they never got final scores, especially in times like COVID, where students had the opportunity to withdraw without scores, so on and so forth. There's lots of different scenarios. But depending on how you select your data, you may affect those GPAs. So here's a better example that actually has a join in it. So, we might say, okay, we need everybody's, we need all this statistical data for students' ACT scores. And so you'll say, okay, I can get that. But some students may not have taken the ACT. And so when you're asked those questions, when you're asked to gather these reports, it's also important, A, you understand your own database, how to pull that data. And then B, if you ever have a doubt, you need to go to your employer and say, hey, how do we want to treat students who don't have a GPA or who don't have an ACT score? Because if they say, oh, if they don't have an ACT score, we don't want to worry about them. Well, that means, okay, we do an inner join between the student table and the ACT table, just as a real quick example. And so that's usually the way it works. Or a lot of it just depends on the business logic of the problem you're trying to solve. So for example, if we want a list of all of our, here's another great example. We want all of our students and their emergency contact information, right? So a lot of times our school sends people, or our district sends people on trips, and we have to have an itinerary on the bus that has everybody's emergency contact information. Um, but let's say that someone's parents never did the registration and never got emergency contact information. If we exclude them, that's probably not a good thing, right? Because they're still going to be on that bus. And so that's one of those cases that a left join is exactly what we're looking for, because we want to see their name. A, so we know that they don't have that information, they can fix it, but B, we just want their name on there regardless. So that's a great question. Um, and it's a tough one because there's not an easy answer, but you can kind of see that depending on, most of the time, it just depends on the business logic you're trying to solve. And right now, it may be kind of hard to imagine, just being able to know right off the top of your head. But the more you do this, the more you practice it, the easier it's going to be to say, oh yeah, I know exactly what we need to do here. So, great question. Any other questions? All these great questions, and I like it. It means it really shows you're getting it. All right. Doesn't look like there's too much. So if there's no other questions, thanks you guys all for being here. If you want some more, uh, like examples, and just dive deep into joins, in the announcement I actually posted a video to a video. I think it's about 45 minutes actually, so it's pretty long, because joins are pretty complicated. All on joins. So if you want to go watch that, if you feel like you're just not quite getting it, go check out that video. I do think it will help because I spend a lot more time just going over joins in idea and concept and theory rather than specifically to the lab. So I think if you're struggling with them a little bit, go check that out. Might help make a little bit more sense. But if you come across anything, let me know. Thanks for all of your great questions and have a great week.